All right, so I wanted to do an example of factoring these trinomials when a was greater than 1. So a is the coefficient for the x squared term when we're talking about standard form. So in this case, it's 2, and here it's 10. And the factoring process is a lot more complicated when we have a number there that's not just 1, when it's not just x squared. So I'm going to go through the x and then box method for factoring. So for the x method, we set this up for ourselves. We multiply the first term and the last term, and we get 18x squared. 2 times 9 is 18. And then we get 9x. That's the middle term that goes on the bottom. So we need to figure out two numbers that multiply to the top and add to the bottom. And so this one is pretty easy. Everything's positive, so we can probably see that it's going to be 3x and 6x. So 3x times 6x is 18x squared, and 3x plus 6x will give us 9x. So that's going to be our solution there. The whole point of that is to divide this middle term to split it. So we're going to split it as 3x and 6x. And that gives us 4 things that are going to go inside of our factoring box. So I'm going to go ahead and draw that out. Factoring box. And we have our 2x squared, our 3x, our 6x, and our 9. Those are the 4 things that are going to go in. All right, and now the factoring process is figuring out the greatest common factor in each row and in each column. I'm just going to start with the top row here. The only thing these have in common is an x. Between 2 and 3, the only common factor would be 1. So we don't need to write 1x. 6 and 9 have a greatest common factor of 3. Then we go to the columns. Here we have 2x squared and 6x. They have 2 and x in common. And you can kind of check as you go, make sure it would multiply out correctly if you're familiar with the box multiplication here. And then 3x and 9 have a common factor of 3. And then again, double checking everything would multiply out correctly. You can be sure that you have factored it right. So our factored form, x plus 3 times 2x plus 3. You could switch the order of those two factors. That doesn't matter. These are the two factors for that original polynomial. All right, not so bad. We're going to go ahead and do the second one here. This one is a slightly harder one because of the negatives. We're going to have to deal with those as we go. So again, multiply the first term times the last term. That's going to give us negative 40x squared and negative 3x. All right, so we need to figure out two numbers that multiply to negative 40 and add to negative 3. Going through this can be a lot harder. We might even need to figure out all of the ways to multiply and get 40. No, 3 is 4 times 10 and 5 times 8. And the question is, which of these numbers is going to be negative? Well, since we know they add to a negative number, that means the larger number has to be the negative number. And then I just need to go through and figure out which of these actually gives us the correct sum. The one that does that is 5 and negative 8. So 5x, negative 8x. That's how we are going to split this middle term here to do our factoring. All right, so the 4 terms that are going to go in our box are just like last time. They're going to be this one here, these 2 here that split our middle term, and that. So I'll fill those in. And then we will find our GCFs to get the factoring. So these are both negative. So when they have a negative 4 as a common factor, these both have x's and they have 5 in common. Here they both have x's, and 2 is a greatest common factor there. And here, the only factor they have in common is 1. And again, as you're going, double check, make sure everything would multiply correctly, which it looks like it does in this case. So our factored form, 5x minus 4, 2x plus 1. And there you go.